we are going to see how it is used. We know that Laplace transform of f of t is equal to f of s, and a is a real number. Then Laplace transform, then by using this damping rule, Laplace transform of e for at f of t must be equal to the f of s minus a. This is formula for this damping rule. We compare this equation and you get that. For example, find evaluate Laplace transform of e for at cosine of bt. E for at cosine of bt. If you get it, you know that cosine of bt, you know its value. If you know its value, you must replace it. We know that cosine of at, the transform is equal, cosine of at, the transform is equal to s divided by a square plus s square. By comparing this equation and this is the transform of cosine of at. No, we are going to calculate, evaluate the transform of e for at cosine of bt, and you know that by damping rule we use e for at f of t, means that for f of s minus a, means for solution, for the first solution, if you have s, you will replace s minus a. We are going to calculate this. Laplace transform of e for at cosine of bt must be equal to, means that this cosine of a must be transferred to b, because this is cosine of bt, and we know that s will be transferred to s minus a. We replace for this, we get s is transferred to s minus a, means it must be equal to the s minus a divided by a power 2. A must be transferred to b, means that is b power 2 plus s power 2. S we know that s is transferred by s minus a, means the s minus a, which is equal to power 2, means that the transform of e power at cosine of bt is equal to the s minus a divided by b square plus a bracket s minus a, which is equal to square. This is solution. How to transfer to e for at sine of at and sine of bt. This is the transform must be equal to, we are going to consider, we know that a here, we know that sine of at is equal to the a divided by s square plus a square is equal to a over s square plus a square. And we know that if we get the Laplace transform of this, for the Laplace transform of e for this, you are going, by using the general formula, we know that fs must be transferred to the fs minus a. And we know that if we are going to use cosine of at and we transfer cosine of bt, means a must be transferred to b. And this solution for a transform of this will get a must be transferred to b, means is b, a must be equal to b divided by s must be transferred to s minus a, means s minus a power 2 plus a must be transferred to b plus b power 2. This is the Laplace transform for e power at sine of bt, which is equal to b over s minus a power 2 plus b power 2. This is your so. We know that the second translation theorem or delaying rule. But know that f of s is equal to the transform of f of t, and a must be greater to 0. means that the transform of f of t minus a union u t minus a must be equal to the e for negative as f of s. This is our formula for this delaying rule. Means that u t minus a must be equal to, with the simultaneous version, must be equal to 0 if and only if 0 is less than or equal to t and less than a. You will get 1 if and only if t is greater or equal to a. This is our formula. Unit step function is called unit step function. If no, there is another of f of t is equal to fs. Means that for when it is here is a, we replace it by this is equal to 1 over a fs over a. This is our formula to use it. We get error for t for n must be equal to the n factorial over s for n plus 1 when s is greater to 0. This is other formula for using this equation. There is so another solution. So we get error for t for n e for 8. The transform of this we know that error the transform of t for n by replacing s must be transferred to s minus a. When you have s will be transferred for s minus a. When you have this transform of e for 8, can you know that the t for n, which is equal to this t for n, is your value is here. By replacing, if you have e for 8, means that whenever you have the s will be transferred to s minus a. The general solution for a transform of t for n e for 8, you will get the transform of this. Whenever you have s will be transferred to s minus a. For here, you will get n factorial divided by s will be transferred to s minus a. Means the s minus a for n plus 1. This is your solution for whenever the s is greater to 0. T for n e for 8, which is equal to n factorial over s minus a n plus 1. There is another theorem. If f of s is equal to the transform of f of t, the transform of f of t 2, 3 up to the infinity, then the transform of t for n f of t must be equal to the minus 1 for n d for n divided by ds for n f of s. This is our solution, our formula to use it. For r which is equal to for a transform of t for n f of t must be equal to the minus 1 for n d for n divided by ds for n f of s. This is for our formula for calculating Laplace transform, for which have the DC form. Of t for n is equal to n factorial divided by over s for n plus 1. Means that n for calculating Laplace transform of t means the t for 1. We get 1 factorial divided by s for 1 plus 1, which will be equal to 1 divided by s for 2. This is what the transform of t. Example, evaluating error t, Laplace transform for t. That for this we use this formula, or otherwise you can use this formula. LT f of t. Means that t for n, this is t. Means that we have L transform for t times 1. Means that t is equal to this t for n, and f of t, which is equal to 1, must be equal to minus 1 for n. Means n is equal to 1, t with t for 1, with minus 1 for n, minus 1 for n, d for n is equal to 1, minus 1 for n, we know that n is equal to 1, for 1, d for 1, divided by ds for n, means d s for n which is equal to 1 times f of s. This f of s, we know that f of s is equal to plus transform of f of t. The plus transform of f of t. We know that if this 1 is equal to that f of t, t for n f of t, means that f of t we get equal to 1, f of t is equal to 1. If f of t is equal to 1, we calculate the Laplace transform of f of t. By using this formula, the Laplace transform of f of t, which will be equal to n factorial. This is a Laplace transform of f of t, which is equal to Laplace transform of 1. Laplace transform of 1, which will be equal to, means if it is 1, is equal to t power 0. If it is t power 0, means that by comparing this equation, means that n is equal to 0. Means 0 factorial divided by s 0 plus 1, which will equal 0 factorial is equal to 1 divided by s 0 plus 1 is equal to s. Means Laplace transform of 1 is equal to 1 over s. Means that for this formula, we put that f of s, which is equal to 1 over s. We will get minus 1 for this is equal to 1 d divided by ds of 1 over s. This ds over this is the derivative of 1 over s. Means 1 over s derivative, which will be equal, 1 over s. We are going to calculate the derivative of 1 over s. 1 over s derivative, which will be equal this. You can be translated s for negative 1 derivative. You know that means negative 1 s for negative 1 negative negative 1 s for negative 1 minus 1, which will be equal to what? Negative 1 times s for negative 2 will be equal to negative 1 over s per 2. By replacing it in this formula, we get here we have negative 1. We get negative 1 times the derivative of 1 over s, which will be equal to negative 1 over s per 2. Negative must be cancelled. We get 1 over s per 2. Means that Laplace transform for t, which will be equal to the 1 over s per 2. This is a way for using this formula for calculating the Laplace transform. For Laplace transform, inverse transform. Yes, for 1, we know that the transform of 1, which is not this. For calculation before, we know that the transform of 1 is equal to 1 over s. Means the inverse means the 1, we are going to see the 1 must be equal to the transform inverse of 1 over s. Means you are going to calculate the inverse of this. For example, we know for that thing which is like for sine and cosine, we know that sine of 3, which is equal to 1 over, which is equal to 1 over s, means that 1 is equal to transform inverse of 1 over s. By overview of that, we know that sine of 30 is equal to 1 over 2. Means that 30 is equal to the sine inverse of 1 over 2. This is the look like for same here. Means that we are going to calculate the 1 which is equal to Laplace transform inverse of 1 over s. This is your solution for here. And here T power n, the inverse transform of this, of n of factorial s n plus 1. We know that the transform of T power n is equal to n factorial divided by s n plus 1. Means that for calculating T power n, we go to the Laplace transform inverse of n factorial over s n plus 1. This is your solution. The transform of sin AT, we know that is equal to as squared plus a power 2. For cosine is looking like same. For Laplace transform, means this is Laplace inverse. Means is here you get Laplace transform of cosine of AT, which is equal to s over s squared plus a squared. And the same as for hyperbolic, there is some difference. For hyperbolic, inverse Laplace transform means that Laplace transform of sin AT hyperbolic is equal to a divided by s power 2 minus a power 2. For comparison with sin hyperbolic and sin only, we have this here. Here we have positive and here we have negative. That is a difference. For cosine of hyperbolic AT, which is equal to this, means that Laplace transform of cosine hyperbolic AT is equal to s over s squared minus a squared. For comparing the cosine of hyperbolic and the cosine, we know that the difference is about this c power 2 minus, here is positive, here is negative. That is the difference. Example of that formula for calculating for evaluate Laplace, inverse Laplace transform of this formula. If we evaluate this inverse Laplace transform of this is you can divide it with this side and with this side. We get inverse Laplace transform of minus 2s divided by s power 2 plus 4 plus 6 over s power 2 plus 4. Now we know that for the inverse Laplace transform is linearity. If it is linear, means that this transform must be here and here. Then your solution you will get inverse Laplace transform of minus 2s over s power 2 plus 4 plus inverse Laplace transform plus 4. You will get inverse Laplace transform of this. This minus 2 must go under here. We get minus 2 inverse Laplace transform of s divided by s power 2 plus 4. 4 which is equal to 2 power 2 plus this 6 must be go there. 6 inverse Laplace transform of 1 over s power 2 plus 4 which is equal to 2 power 2. But for this equation, we know that s over s squared plus 2 power s. We know that for the sine, for example here, for the cosine of AT, we know that the Laplace transform of cosine of AT is equal to s over s squared plus a squared. We are going to write this equation. We know that Laplace transform of cosine of AT is equal to s divided by s squared plus a squared. By comparing this equation and this, means Laplace transform of means that Laplace means that cosine of AT is equal to inverse Laplace transform of s over s squared plus a squared. I repeat this. This is equal to this. Means that by comparing this equation, you know that a power 2 power 2 means that a is equal to 2. That will be equal to the cosine of AT. We are going to see minus 2 inverse Laplace form of this, which is equal inverse Laplace form of this, which is equal to cosine of AT. Means cosine of a which is equal to 2t for this solution. And here we get 1 over s power 2 plus 2 power 2. If we have this equation, we have for comparing this, we know that sine inverse Laplace, we know that is equal to a over s squared plus a squared. And we know that sin AT is equal to inverse Laplace transform of A over S square plus A square. By comparing this equation and this, we know that if we have the A power 2, means here we have 6. If we have 6 are the factor which is equal to 2 times 3. Means here are 2 times 3. If you remain here with a 3, here we get 2. Because 2 times 3 will come to that 6. If we have this, by comparing this equation and this for the sign, we get A which is equal to 2. A which is equal to 2. And if we have A which is equal to 2, this equation and this are the same, we remain with 3. This inverse Laplace transform will get sin of AT, means A which is equal to 2, means it is equal to sin A which is equal to 2t. By adding this equation, for that equation we have minus 2 cosine of 2t, means the solution is minus 2 cosine of 2t plus this equation which is equal to this, plus 3 sine of 2t. This is your solution for this equation. For calculating this inverse Laplace transform is equal, your general solution you get is equal to minus 2 cosine of 2t plus 3 sine of 2t. This is a way for calculating the inverse Laplace transform. This is the way for calculating the inverse Laplace transform, as we know that L cosine of AT is equal to S over S squared plus A squared, which is equal to A which is equal to 2. And you replace it from its value in order to see that equation. This is the way for calculating that. You know that L Laplace transform of sin AT, which is equal to A over S squared plus A squared, which is equal to this. If f of s is equal to this, we know that by the general formula, we know that the Laplace transform of f of t is equal to f of s. Means that you are going to calculate f of t. Means f of t is equal to inverse Laplace transform of f of s. Now, f of s, we know its value. We are going to calculate inverse Laplace transform of this formula. Means inverse Laplace transform for 2s plus 3 divided by s power 2 plus 4s plus 13. For this formula, we are going to translate this form into the form of, into the bracket form, s power 2 plus 4s plus 13. We know that by the general formula, we know that the a, for example, a power x squared plus bx plus c, which is equal to 0. We know that for transforming into the form, we get x plus b. We take this b over 2 power 2 minus this which is equal to square b over 2 power 2 minus you add this c. This is how to form for transforming which is equal to 0. We are going to transform this form into this. For here we get s plus this b which is equal to 4, means in 4 over 2 we get 2 power 2 minus this b over 2 power 2, means it's equal 2 power 2 which is equal to 4 plus 13. We get s plus 2 power 2 minus means plus 9. This is where you transform this formula. Then you will get the Laplace transform of 2s plus 3 divided by this s plus this. We are transforming into this form. We get s plus 2 power 2 plus 9. 9 which is equal to 3 power 2. We know that if it is here, we can divide in this side and with this side. We get inverse Laplace transform for 2s divided by s plus 2 power 2 plus 3 power 2 plus inverse transform plus inverse Laplace transform for 3 over s plus 2 for 2 plus 3 for 2. Compare it with this form, the form which we have s plus 2. We know that if it is s is a cosine. We know that cosine of 80, the Laplace transform of this is equal to s over a square plus s square. And for here, we see the Laplace transform of e power 18 of cosine of 80 is equal for whenever for b, if here we have a will be transferred to b, s can be transferred to s minus a. The solution we get for when we have s minus a divided by a will be transferred to b. For this solution, a will be transferred to s must be transferred to this. A will equal to b power 2 plus s will be transferred to s plus s minus a, which is equal to power 2. For comparing this equation and this equation, we get s minus a must be equal to the s plus 2. S must be cancelled. We get minus a, which is equal to 2. A is equal to 2. A must be equal to negative 2. And also, this equation and this, for above, 2s is equal to s minus a.